Hi, so we're here today with Neil Langmead from Amenda. Amenda is a software consulting company that specializes in helping companies with a variety of software quality challenges. Today, Neil's going to talk to us about technical debt. So Neil, what is technical debt?
Hi Nero. Well, technical debt is the accumulation of a backlog of technical work for a given project. It typically includes tasks like documentation, testing work, a slippage in the plan. Like any debt, if you consider financial debt needs to be repaid at some point. Any other kind of debt needs to be repaid. And most people, I think, appreciate that the cost of repaying a debt later is often significantly more than, firstly, if the debt is never acquired in the first place, secondly, if the debt is paid very early in the process. So the longer you leave technical debt in a project, the more expensive it is to fix, the more difficult it is, the longer it takes to catch up on a project plan. So good examples are maybe version 1 of a project. You start with a great plan, a great architecture, a great time scale. We're going to ship in January and everything's working to plan to start with. But then things happen, bugs come into the system. Some of those bugs we don't know how long they're going to take to fix, to eliminate. Project requirements change, typically in an agile project. Developers, like all other human beings, decide that their main interest is actually the creative part of the job. So they're implementing features and they're busy prototyping and going ahead and implementing some fantastic new ideas and features. Whereas maybe they're not so concerned about the test. They realize that there's a quality backlog building up. They need to do the unit tests, for example, for a safety critical project. But, well, we can do that later. Let's just get these features implemented first and catch up. And that's the kind of typical scenario that many projects find themselves in, where there is that delay that's crept in. We know that there's documentation to be written. We know that the source code doesn't match the architecture. We know already that the changes that are coming in haven't been regression tested. But let's just ship out version 1 first, and let's meet our delivery requirements and meet management expectations, and then we'll catch up on that later. And that's the typical situation. When you hear those kind of comments, there should be an alarm bell ringing that this project is in some technical debt. It does take some time to repay that. As I say, the longer the debt is not addressed, the more expensive it becomes. So typically in an architecture, if you've got some software, you've got some code, you've got some application. Maybe this is your application level or your UI, and you have different tasks that your software that you're designing. Let's call this T1 to Tn. And then here you have individual modules that are inside this task. And typically in an architecture at the bottom, you've got things like your libraries, your operating system code, your utilities, things that are used heavily but don't use anything above it. So you tend to work hierarchically. Well, let's say, for example, that even if you don't change your code at all in one day, this is your code base, your project is liable to acquire technical debt. For example, most applications are using third-party libraries here. Let's say that this third-party library changes. Then even without your application changing, there's an implication for tests. Does your version work with the new updated library from a third-party supplier or from an external source? So that's kind of an example of how we need to consider technical debt and some examples of how it creeps in.
Right. So, Neil, if I was a software developer and I'm working on a project, how would I know if I have technical debt?
Well, the old saying goes that you can't manage what you can't measure. So you need to have good KPIs in place to measure the quality of the software. Those KPIs can include things like complexity metrics, which a unit testing solution like VectorCast would obviously manage and measure for you. Complexity is a good place to start. It's what does my software look like? Are there any outliers? Why is this module here, for example, this s.c where I've written my big stack, why is that 10 times larger than every other module in the system? I'm going to need to put 10 times as much effort to get my full unit testing done on that component. So we need to look for outliers, we need to do a baselining of the software, we need to measure through our analytics to have a look at and see, for example, in a heat map or across a dashboard, where the problem areas are likely to be. You can't manage what you can't measure. Measurement gives you the information that you need, exposes what's happening in the software. So for example, a simple analysis would yield a dependency structure. Have you got the architecture that you originally planned? Are you ready to do unit testing? If you have spaghetti code, and what often happens is, I'm a developer here working in this module and I need to write a stack. Well, I wrote that up here in this task, so let me just call that header file up here. I'm reusing some code which sounds good, but inadvertently I've introduced a cycle. And so the sort of mathematically speaking, the transitive closure of a change in any of these components is going to give me a technical debt, because any change in this module now has unintended consequences in another part of our system. But that's another expression of technical debt, is the transitive closure of a change in the system. If I make a change, how much of an impact is this going to have on the rest of my system? What's it going to cost to retest this system?
Okay, very good. So are there some very simple metrics that if I went and looked at my project today, I could quickly see if I have this kind of problem?
Code coverage is a very good measure. If we have a set of tests, a set of unit tests and integration tests that we know give us full coverage of, let's say this is version 1 of our software, gives us full coverage and full testing of the software. And by testing, I mean not just requirements-based testing, I mean things like equivalence partition testing, boundary value analysis. So the mathematical theory says that the problems in software occur at the boundaries of partitions, so the minimum, the maximum numbers. If we build a test strategy where we're doing equivalence class testing, partition analysis, boundary value analysis, fault injection, and requirements-based testing, and we know that our tests give us full coverage, then we can use that as a baseline, and then any changes are measured against that baseline. So typically we end up in a code, so we have a coding phase, and then we have a testing phase, and then normally we have a debugging phase as well. That's a typical work of a developer, but if a developer's under pressure, there's a tendency or a desire to skip the testing and debugging phase and just go straight to shipping and to release. And often then we're releasing software with a technical debt, with an unpaid technical debt and a load of quality issues that will at some point need to be addressed. The worst scenario imaginable is if our customers or the users of our software obviously discover the faults, report back to the development team that software crashes with our inputs. That then is obviously a loss of brand, a loss of reputation. In a safety project, it could be catastrophic as well if software is being released into the field with that known technical debt.
Wow. So, Neil, I mean, how big a problem is this? I mean, do you see many people out there?
I see 95% of projects acquiring some technical debt. Why is that? As I say, even the null release, and we define the null release as follows: the time it takes for you as a project to release a new version after one line of code that's changed. So you're changing one line of code, how much time, testing effort do you need to make in order to up-issue and release the new version of your software? You want that to be a minimum. The way you achieve the minimum is high levels of automation. So you want a change-based testing approach where you make a change and the impact of that change is instantly assessed. A tool like VectorCast and managed, obviously, by monitoring the file system, checks to see which tests need to be recompiled and which need to be rerun in the event of any change on the file system, which is exactly what you want. You want thousands of test cases. Software's getting larger, it's getting more and more complex. So you often have tens of thousands of unit test cases, many of them automatically generated. You maybe don't have time to rerun them all, so you want to know that with this change, which parts of my software are affected. So you need a change-based testing approach to keep that technical debt to a minimum.
Okay. So, I mean, what sort of customers have it? Because this sounds like a pretty challenging situation. Is this something that's limited to a smaller business or a bigger business? Or, I mean, what sort of companies do you see having these kind of issues today?
We see customers in all vertical segments with a technical debt issue. Obviously, in the safety space, where formal testing is a larger overhead than perhaps in a less regulated industry. So formal testing obviously takes more time, maybe consumes more of the development lifecycle, estimates of more than 50% for a safety critical project. Technical debt very quickly builds up there, particularly when the code has to be kept in sync with documentation and maybe the architecture in something like Enterprise Architect or the model. So we see technical debt very clearly in those situations in safety critical, but also in pretty much any other software project where there is a set of requirements, changing customer demands, particularly an agile framework where customer says, well, I want this button to be green and not red, even the small changes. We see the build-up of technical debt. It's very easy for technical debt to come into a project, and so it does need to be managed and measured.
Okay, so Neil, I mean, this all sounds pretty daunting, and it seems like there are a lot of kinds of software businesses and just generally businesses that are trying to enter into software that are having this challenge. I mean, is it really a problem? Is this hype? Is this, the next kind of, year 2000 bug, Y2K bug, or is this really an issue? I mean, are you seeing businesses really finding challenges here and trying to work through it?
We are finding every day in the papers, in the press, stories of software failures, stories of release schedules slipping, software not being released, devices not being ready because of software problems, firmware updates, crash-causing instances. There are so many projects that have been delayed because of software faults. If we trace that down, very often I believe we would find that that's due to a technical debt where the business side has put pressure on the development team to release something perhaps before it's ready, or the estimates in the first place haven't been correctly managed. Expectations haven't been set correctly by the development. It takes a long time to develop good quality software, and if we don't have a culture of building quality in from the building blocks upwards, from the bottom upwards, then we will get technical debt. It's a very big problem. It's a huge problem in the industry. It particularly affects large projects where there is a legacy code base. I visited 2 customers today in London. We're talking applications now, 20 million lines of code is quite common. One person even told me today their code dated back to 1975. The original developers have long gone. There's no documentation. There's a need to understand quickly what this code is doing. There's also a desire to refactor and reuse that code base. Everybody wants to reuse. That makes sense economically and technically, and from a business point of view. Let's reuse code that's already been done. But you need to obviously understand that code. And that's where something like VectorCast, if you are in that situation where you have a legacy code base, not very well documented, perhaps not so many tests that have been run against that, use the baselining to generate the actual behavior, to record the actual behavior of the software. Then if you're happy with the behavior of those components, set the actual to the expected behavior, which is easily achievable in the solution. Then you have a baseline to manage changes going forward, and then you can manage deltas, and you have a confidence to go forward, knowing that you've got full coverage, the tests pass, and that you're managing the change. So I think change management is what we need here. Also, it's very noticeable that if you looked on something like LinkedIn, there are now job titles called complexity managers. So software is getting so complex that there are specialists now who are managing that complexity and having to deal with this complexity. So if you have an architecture which is maybe not the intended architecture, not a hierarchical system like this, but maybe you've got some spaghetti code, you've got some clustering, you've got some dependencies that are causing some issues, tests that affect other parts of the software that shouldn't do, then we can analyze that, and then we can start to baseline the behavior and then make positive changes going forward. So yes, I think it's a big problem, but thankfully there are advanced technical solutions out there to address that problem.
Okay, Neil, so if I went home today or went to my office today and I started looking at my code and using the metrics you mentioned earlier, I found I had a problem. What can I do to address these issues? What are some simple things, or how can I start paying back some of this debt?
So let's say you have some technical debt. We've identified that the software isn't behaving as it should do. We've identified perhaps that the documentation is out of sync with the code. We've identified there's not enough code coverage. The first thing you need to do is to bring in robust testing tools that provide as much automated support as possible. The complexity issue that I've mentioned means that we cannot do this by hand anymore. It makes no economic sense to do it by hand. Doing work by hand that can be automated is error prone. Developers are likely to make mistakes. We have robust solutions in VectorCast, in the test harness, in the test case generation, the automatic test case generation, the coverage and the analyzer, and the manage solution that automatically do this work for you. So the ROI is very high in using a tool like this, particularly on a large code base. The investment in the tool is more than repaid by the time saving. So use the tool to generate the test cases that should have been written maybe years ago on the application to verify the behavior. That catches you up pretty quickly. We often find with many modules you can get 100% code coverage and also prove that there are no buffer overflows or no underflows or no denial of service attacks. We can do all these things through the dynamic testing engine. So the first thing to do is measure the technical debt. We have a dashboard system that can be used to compute the number of days that we would estimate it would need to complete the project to a certain code quality level, a functional safety standard, for example. So we'd have an estimate of maybe 50 days to complete the coverage and testing work on a project, and then obviously apply the baselining to catch that up and do in a matter of minutes, hours, what would normally take days, months, or even in some cases years if we did it by hand.
Very good. Thank you for that, Neil. That's fantastic.
Thank you, Noah. Thank you.